Hi everyone, welcome back to the channel. Today I'm going to be showing you everything you need to know to get started with the Azure Speech Service, how to add it into a web app, and also how to deploy it end-to-end onto a service like Azure Static Web Apps. I've seen a lot of intro videos talking about the Azure Speech Service, but not a lot of them where it actually tells you how to deploy it as a whole, and a lot of the videos are kind of outdated as well, so I thought I'd make one myself. So this is what we are going to be aiming to build today. Just a simple interface for the speech service. We've got a section for speech to text and another section for text to speech. For the speech to text section, it is a continuous recognition. So I'm just expecting it to record my voice and basically transcribe what I'm saying. And we can try it out. Speech service is awesome. And as you can see, a transcript is generated. As for the other section, it is text to speech, basically just an AI generated voice. If I type here speech service is awesome, I should also expect it to say
Speech service is awesome.
And yeah, it works.
Speech service is awesome.
I just wanted to briefly talk about what we are going to look at in this session. The first thing we're going to check out is how you can create an instance of the Azure Speech Service on Microsoft Azure. Then we are going to implement speech to text and text to speech on a React Vite application. If you're wondering what Vite is just the modern way of creating React apps. It is just far more efficient than create React app. And after that, we're going to check out this thing called ephemeral tokens for key management. Basically just the best practices for storing your keys in a production app. And once we're done with that, we're just going to deploy the application onto Azure Static Web Apps so that your website is live on the web. So let's see how we can create an instance of the Azure Speech Service. The first thing we need to do is just to go to the Azure portal, and we can do that by typing portal.azure and log in. Once you're here, we just search for speech service and it should pop up right here. Now I've already got a few speech services created, but if you don't have any, just click on create and it should bring you to the creation page. Choose your subscription. I only have one. And as for your resource group, this is basically just how you group together common resources for a single project. For this demo, I'm just gonna create a new one. Gonna name it test speech service demo. For the region, I'm going to go with Europe West. And now we need to pass it a name. This name can be anything, but it has to be unique. I'm just going to go with Speech Service Basic Intro 1, 2, 3. And now we have to select our pricing tier. If you have a student account, you should see the free option right below. But as you can see, I already used my free tier option for another instance of the speech service. So it's not going to be appearing for me. And for the demo, I'm just going to proceed with a standard account. Click on Review plus Create. It should run some validation checks, and it's passed. So we just proceed with creating it. Now it's being deployed. It should be deployed rather quickly. And here it is. It's done. Now we are in our resource. So the only important thing to know about in this page is your keys and your region. This is all we need to know in order to integrate the speech code into our application. I guess other than that, you can check out the Speech Studio. It's basically just a place for you to manage your speech projects. And another cool thing about this page is that it shows you every feature that you can work with on the speech service. And some of them even lets you try the features out in the application itself. For example, this is a text-to-speech one, and you can try out the actual voices. So this is Jenny, and you can make her say things.
Many think that the people you list as references are...
So yeah, have a look around the Speech Studio and find out what you can work with on the speech service. Next, we are going to take a look at how we can implement some speech features into our web application. And I basically just have a few slides to go through first before diving straight into the code. The first slide I want to go through is just about asking where do we even add the speech service code. And as I mentioned before, we are going to be doing this in a React application, so the code should be located inside the front end. And I know this sounds a bit like redundant, but I wanted to bring this up because not too long ago, I actually didn't know about this and accidentally implemented it in a Blazor server application. It worked fine locally, but when it came to deployment, the server was actually deployed on a virtual machine on the cloud. And guess what? The virtual machine is programmed and it does not have access to a physical microphone and a speaker, so I ended up having to rewrite it somewhere else. And I think it should work for Blazor Wasm because it's a front-end project. So the TLDR of this story is just implement the speech service code in a front-end application. So to install the speech SDK into your application, all you need to do is to type npm install Microsoft Cognitive Services Speech SDK, and it should be added into your project. Next, we're going to take a look at speech-to-text continuous recognition. So this is basically just a feature to transcribe your voice in real time. There's another speech-to-text to transcribe audio files as well, but I think continuous recognition is much more cooler, so I'm going to showcase that instead. So to do that, the first thing we need to do is just to create a speech config, and this is basically just a way for us to connect to our speech resource in the Azure portal. And we're just basically passing in our subscription key and region, and both of these values can be found in the page in the Azure portal. Next is to create a audio config, and we are just basically telling it to get our audio from our default microphone. And from those two objects, we can just create our speech recognizer. So the way speech recognizer works is that it is run asynchronously, and the way to interact with it is by subscribing to its events. And the speech recognizer essentially supports these 4 events: the recognizing event, the recognize event, the cancel event, and the session stop event. So basically you can pass some event listeners to all of these events, and this is basically just me telling it to run a function called set transcript every time it recognizes something from my speech. And to start and stop the speech recognizer, it's also fairly straightforward. To start it, you just call the start continuous recognition async function, and to stop it, you just call stop continuous recognition async. On the other hand, here's the code for text-to-speech. We also have to create a speech config first, and here you can actually see my key and my region. But this is a free account, so I'm gonna delete it anyways. And the additional things that we pass through this speech config is the language, and I set it as English. And we also pass it a speech synthesis voice name, which is basically just a voice profile. And I just went with the default one, which is Jenny, like the one you saw in the Speech Studio tryout section just now. The code for text-to-speech is actually more straightforward. You just have to create an audio config, and I'm basically just telling it to pass the synthesized audio to my default speaker, and from there you can create a speech synthesizer. So there's only one function that you really need to know about, which is the speak text async function. It takes in an input, and this is basically just what you want it to say. I'm telling it to say speech service is awesome. And the second parameter is a callback function, basically what you want it to do once it's generated some audio. So this callback function looks a bit weird, but let me explain. Basically what the speech synthesizer does is that it doesn't synthesize like audio directly. Instead, what is under the hood, it actually synthesizes an array of values to represent the sound. So, and that thing is actually stored in this result object. It's actually the audio data, but basically, once you got the result, you can close the synthesizer because you no longer need it, and you basically just return back the audio data, and that is passed to the speaker. Next, I'm going to show you how you can store your keys safely. In the previous examples, I was showing you how you can create a speech config by passing in your speech subscription keys directly. But in a production app, that might not be the best approach, because if you are using a paid account and you're leaving your keys in the front end, that means that your keys are going to be exposed for everyone to see, and someone else might take your keys and use it for themselves. So the solution for that is to use something called ephemeral tokens, which are basically just temporary authentication tokens, and it essentially expires after a certain amount of time, like I think it's 10 minutes. And the cognitive API actually provides you an endpoint for you to issue these temporary tokens. All you have to do is to pass in your speech key and you can get a temporary token. And we basically want to call this, like handle all this logic in a backend function, because a backend function is safe for you to put your keys there. It's generally more restricted, and I guess only the developer has access to view the code in the backend, so that's why it's kind of safer. So the workflow you want to achieve is something like this. Every time our front-end application loads, we want it to make a HTTP request to our backend to issue a temporary token, and our backend will basically just get our speech keys, pass it into headers, and make a call to the cognitive endpoint to issue a token, get the token, and send it back to our front end to use. And basically for our backend. And as for the backend, I just decided to use Azure Functions, as it is a very lightweight way of writing backend APIs. All you have to do is to define the logic, and Azure will handle the rest. So here I'm using a HTTP trigger, and all that does is that whenever the endpoint is hit, this entire function will run. So imagine if this function was called get speech options, and whenever I type like get speech options in my URL, this entire function will be run. And here is the rest of the code for setting up the temporary token. So in the main entry point on my front end code, I would have a use effect hook, which basically just runs these functions whenever the page is loaded. I will make a HTTP request to the API/get speech config endpoint, which basically is this function, and it should return me a token and a region, and I'm going to set it to some global state, and from there I'm just going to replace every instance of my speech configs to use an from authorization token function instead, because our keys are now based on an authorization token. And yeah, I think that's all the code we need to add into our application. Alright, let's just dive straight into the code from here. Alright, what I have here is the application that I showed you earlier. It's basically just a React plus Vite application. You can see it's running Vite here. And it has an API layer written in Azure Functions. And the rest of the code is located in the source folder. And all you honestly have to focus on is the component section and the app.tsx file. The app.tsx is our entry point, which is this file. I guess if you want to install the speech SDK into your application first, the first thing you need to run is this command, and it will basically install the speech SDK into your application. But I already have it installed, so I'm not gonna run it. And what I have here in my entry point is that I have two applications. One of them is App Basic, which is the most simplest way to set up speech to text and text to speech, and also another application for the proper setup that includes all of that temporary token logic. And the way you can change the applications is just by changing the export default line. If I want the basic app, I just use export default app basic. If I want to use the proper app, I'll just like export default the app. And yeah, we can first of all like just run this application to see how it is right now. And by the way, I'm using pnpm because it's a much better version of npm, so check it out. And you can see here we have a rough template of our application. Everything is not working right now because I basically just commented out all of the relevant code, and I'm just gonna walk through how we can. I'm just gonna visit those codes later on and see how we can enable all of these speech services features. And yeah, let's just look at the speech to text component first. So all of the key code are commented out right now, and let's just see what we need to add to. Let's just see what we need to uncomment to enable that speech feature again. So the first step is to add the speech config, but I don't have my key here, so let me just look if I have another component which has the key. Nope, I guess I'll have to fetch the key myself. Alright, I got the keys. Basically, just like the slides before, we need to create a speech config to connect to our subscription. Then we need to create an audio config to tell us where to get the audio from, which is our microphone. Then we just create a speech recognizer. And as I said before, speech recognizer is kind of running asynchronously, so we have to subscribe to certain events. Basically, the only important event that we need right now is the recognize event. And basically what it does is that whenever we recognize a certain word from our speech, we just basically call this function called set transcript, which is basically just this component. And we're just appending the result to whatever we saved before. And that's the only event we need to subscribe to, honestly. Then we essentially have two buttons, start recording button, two button handlers, one to start the recording and one to stop the recording. And as you can see, like, they are used in these two buttons. So on the start recording button handler, we just have to enable the continuous recognition async function. And then on the stop recording function, we just have to call the stop continuous recognition async function. And that's pretty much it to get your speech component working. Let's just test it out. Looks like it's working. Speech service is awesome and easy to implement. It only takes like 10 lines of code. And yeah, like we got that working with just 10 lines of code. Pretty insane. Alright, next, let's just take a look at the text-to-speech component. And this is all the code that we essentially need, just like 15 lines of code maybe. And same as before, we just need to create the configs. So here is a speech config to connect to our speech resource, and we just provide a language and a voice profile. And here is the main logic that we need. So the first thing we need to do is to create an audio config, which is basically just telling it where to play the sound from. And then we create a speech synthesizer, and here is the main function to synthesize the voice. So it takes in an input of what you want it to say, and a callback function of what you want to do once that audio has been generated. Not the audio itself, but like the audio buffer array. And basically this input box .current.value is basically just a reference to my text area. Basically this text area. So whatever I'm typing here would be the input for my speak text async function. And another thing I forgot to mention earlier is that this audio config must be initialized every time you call the synthesized speech function, because of the way the browser works. It's pretty hard to explain it, but if you put this outside of this function, you get an error, and it's a very nasty one. So, and if it's kind of hard to explain it without diving deep into how browsers work. So for the purpose of the demo, I'm just gonna skip it, and yeah, just know that you have to put like this audio config inside of the function every time. And let's test it. Let's just copy the input here. Get it to say the same thing. Maybe let's say like 50 lines of code.
Speech service is awesome and easy to implement. You don't need. Takes like 15 lines of code.
And yeah, like that's essentially all it takes to get speech features integrated into your application. And yeah, I think that's it for the basic setup. Now let's take a look at the proper setup with the authorization token logic implemented. So the main difference here is now I have a state to store my speech key and my speech region on the front end, and these values will be populated by getting the values from my Azure function backend. So I basically have a use effect hook which allows me to run functions when the page is loaded, and I'm just making this API call to this API/get speech configs endpoint, which is my Azure function, and we can look at it here. And all it does is to get my speech key and region from my environment variables. pass it into the headers and send it into a request to the cognitive API endpoint to issue a token. The token will be stored in this token response, and I'm basically just going to extract them and pass it back to my response body, and that will be in here, token and region, and I'm using those values to set my speech options. And from there I can pass this state into the speech to text and text to speech component as props. Let's just take a look at them to see what's different. Yeah, the main difference now is that it now takes in a prop for speech options. This is the values that contains our temporary authorization token and our region. And the other difference is that now the configs are being passed inside of this start recording function. Previously it was located outside, but since now you need to get the key and the region from the props, it has to somehow be inside of the function. Honestly, I can set this up using a use effect hook, but whatever works, as long as the config is inside, and it doesn't hurt to create them from scratch every time. And the other difference is that right now I'm using the from authorization token because the keys are not the subscription keys anymore. And same as before, I have an audio config, create the speech recognizer, subscribe to the events, and basically I can start calling the start continuous recognition async function. And I guess for the stop recording function, I just have an extra check to see if the speech recognizer has been initialized, and if it is, I'll just call the stop recognition async function. Other than that, pretty much the same code with the basic setup. As for text to speech, it also now has a prop to that you can pass in for the token and the region. And yeah, the main difference now is just that the speech config is located inside of the function itself, and it is using the from authorization token function instead, because yeah, now we are using this temporary authorization token. The code is pretty much the same as the basic setup other than that. And now we can try to test it out. But first, I think we need to get our Azure function running, and to do that is very simple. We just need to click on F5 on the function itself. Alright, got my functions running now. I had an issue just now. I just had to restart my Visual Studio Code. But basically, let's try it out. The only way you can see our functions being called is if we open up our network tab. And let's try it out. Is there any errors? No errors. Let me just open this up. And we should be able to see an... Oh, turns out we forgot to change the app we want to export. Right, let's try out now. Yeah, and here we can see like the get speech config endpoint is being hit, and you can see that it's returning us a temporary token. Speech service is awesome.
Speech service is awesome.
And yeah, it works just as expected. I guess something that I didn't really mention is that we still have to add like some logic to manage when the key is expired, so we need to know when to refetch the token. But that is slightly out of this demo. And if you're interested, there are a lot of examples of how you can set that up online. So I suggest you check that out. And yeah, this is all you need to know to integrate speech to text and text to speech into your application. And from this point on, you're free to build whatever you want with it. What I had in mind was to just provide this as a template on how you can integrate these speech features. And all of the code is available on the GitHub, on my GitHub account. And yeah, just search for my username / intro to Azure Speech Service if you ever want to use this template. And from that point onwards, you can pretty much build whatever you have in mind. For example, I tried to integrate OpenAI's completion API into this application, and I can showcase it to you. So I already made a OpenAI component ahead of time, and I'm just gonna import it over here. And yeah, Copilot already knows what I want to do. And let's try it out in the demo. Nice, I have a third component here. Let me just refresh. And let me ask it some questions. Tell me why speech service is awesome in a short sentence. Let's wait for it to process.
Speech Service is an amazing tool for recognizing and synthesizing speech, making interactions with technology more natural and efficient.
And yeah, a lot of cool things you can build with speech services. And the final step is to deploy this application onto Azure Static Web Apps, and I think it's quite straightforward as well. Let's go ahead and do it now. The first thing we need to do is just go back to portal.azure, sign in, search for Static Web Apps, and click on create a new one. And from here, just select back the resource group that you want, enter a name for your static web app. I'm just gonna try test speech demo. It's a free project, and I want it to be in Europe West as well. And deployment source is from GitHub. So it's actually this repository, and I can just select that one. Let me just find for intro to speech service main branch. And this is actually a React application, so we can just go with React. So as for these values, it would be dependent on the way we structure our application. Let me just show you. So for the app location, this is relative to your main repository, and I actually have the code here instead. So it's relative to this main directory. So a slash here is assuming that your source code is also in this page, but it is not. My source code is located in the intro speech app right here. So we have to change this to /intro speech app. And as for the API location, it is also located in intro speech app /API. So that's the path we're going to put in as well. And this output location is dependent on the framework the framework you're using to build your output. Sometimes it can be named build or dist or out. And in our case, let me just check what's our build output. And you can check this by running your build function. We need to go to the project first and pnpm build. And I can see here that we already have like this folder for our build. So we should put it as this instead. And that's all we need. Click on View plus Create. And click on Create again. And from here, you can go to your GitHub repository, click on Actions, and you will see a new job being added. And a YAML file, which is also added, which is based on a new name. I know the new, like the static web app here, it's gonna be Lively Send, because Mango Meadow is the app that I've already deployed. And yeah, now you just have to wait for, I think, like 2 minutes. And here's some editing magic. And looks like we are done. But this one's failing and this one is passed, which is weird. I guess the step that I forgot to mention about deploying your web applications is that a crucial step that you always have to do is to pray that your deployment gets out, because things are weird. Like, let's take a look at the issue. We are currently experiencing problems communicating with our content server. So apparently this is it's a issue to do with the Azure service. So I don't think it's really much of an issue, because these two jobs are the same ones. It's just like doubled, and for some reason this one passed. So I think it's working. We can actually just try it out. And here's Lively Sends. Wow, this is weird. There's another error authorizing the speech key. So it turns out I was getting this issue because I forgot to add my speech key and speech region into my environment variables. So to do that, we can just go back to static web apps, click on the web application that we just deployed, go to configuration, and under application settings is where we define our environment variables. Click on add, and what we have to add here is our speech key. This is just from my free account, and the button is here. And we need to add our speech region as well, and it's just Europe West. Let me just double check. West Europe. And click on save. And basically, once you've added your environment variables, your web server should just refresh. And let's see. Yep, it goes through now, and we have our token. Speech service is awesome.
Speech service is awesome.
And yeah, this is how we get our application deployed live on the web. You see, anyone can access this link. And yeah, that's all for the demo. If you want to use the template, just go to my GitHub. Intro to Azure Speech Service, and feel free to just fork or clone this repo. And yeah, that's all for the video. Thanks for watching.